Sathyabama Institute of Science and Technology.
Good morning. My name is R.Yugha. I am from Department of School of Computing in Sathyabama Institute of Science and Technology. Today I am going to talk about introduction of Internet of Things, that is IoT. IoT in the sense we can able to access our environment data through our mobile or anything, whatever it is. My today agenda is first one introduction, characteristics of IoT, application domain, evolution, trends and current status, and future prospects of IoT. And then IoT devices versus computer, trends in the adoption of IoT, relationship with embedded systems, and technologies used in IoT, and IoT reference architecture, physical and logical design of IoT, benefits of IoT, and what is the limitations are. In the introduction part, interconnected of physical devices such as applications and vehicles that can be embedded with software, sensors and connectivities, which enables these objects into an exchange and connect with the data. These technologies can allow the collection and sharing of data from vast network of devices and creating the opportunities which is more efficient on automated systems. And in the upcoming years, IoT based technologies can be offered level of services, and also practically we can change our people lead their daily life. In the advancement, we can IoT uses a lot of applications like smart medicine, smart healthcare, smart industries, and various applications. Nowadays we are using that. And over 9 billion things of devices are currently connected to the internet as of now, but we are in 2023. Definitely the connected devices will be increased. In IoT, we have a main components. One is the low power embedded systems, sensors, control units, cloud computing, availability of big data, and networking connections. These are the main important components of IoT we have used in that. Low power embedded systems in that, which means that IoT in the sense we use our IoT sensors devices, so it will be definitely it will be a power consumption. So less power consumptions, high performance or the inverse factor that can play a significant role of the domain. And sensors, it will be a physical device, can be used in a perception layer of IoT, which can be measures and detects our certain physical quantities and converts it into a signal which can be provided as the input to the processing of unit, and it will be passed to a control unit. In the control unit, it will be responsible for major processing work of IoT devices, and all logical operations will be carried out here. And cloud computing, in our physical environment data will be stored in the cloud platform. Here we are a massive amount of enormous amount of data will be used in the cloud computing, so we require a lot of storage in that. And next one is the availability of big data, which means that we can handle our IoT real time data. We definitely the big data will be available, and we are required to connect our devices. Between that, the network connections will be a prominent role. Next thing is IoT enabler. We have four types of IoT enablers we have. First one is RFID and sensors, nanotechnology and smart networks. RFID in the sense radio frequency identification. It uses the radio waves in order to electronically track our electronic IoT devices. And sensors, it will be able to detect the changes in our physical environment like a motion detectors. And nanotechnology, it will be named such as that it will be a tiny devices with dimension less than the 100 nanometers. Smart networks, in our IoT we can use our mesh networks. Mesh network in the sense all the devices are connected with each other. Now working with IoT devices, first collect and transmit the data, actuate devices based on the triggers produced by sensors or processing devices, and receives the information again back. And communication assistance, we have using the communication assistance in that we are using the some of the protocols we can able to collect the data and transmit the data and also receive back in that. In between that, we have using the communication assistance, we are using the some of the protocols like CoAP, MQTT, like that. And next thing is the characteristics of IoT. We have 6 characteristics. One is the intelligent, next one is the connectivity, expressing, sensing, energy and security. Intelligent in the sense, we are collecting our physical environment data, so it is a raw data. So we know, as a user, as a normal user, we can't able to trust our data. In the intelligent way of data will be sent to the user in the sense, this is the one of the main characteristics in that. And connectivity, definitely our environment, physical devices will be connected to the internet in the sense, the connection is very important. And expressing, that data will be expressed to our users. And sensing, it will be sense our physical environment data. It will be also use that based on the user requirements, our sensor IoT devices will be placed in that. And energy is a major one of the characteristics, because sensor devices will be a power consumption devices, so it is a working with a battery life. So energy is one of the main characteristics, and security is more important that because we are handling IoT devices, we are handling the critical and sensitive data also, so security is more important one. And next one is the application. Application in the sense, it will be a, now IoT incorporates trillions of sensors, billions of smart devices and millions of applications. Now 4 major popular domain we are using the IoT. First thing is manufacturing and industrial business is 40.2%, healthcare it is a 30.3%. Next one, we use the security, right? It is a 7.7%, we are include that. And last one is the retail, it will be a 8.3%. And some of the modern technologies like smart grid and energy savings, smart cities, smart home and smart automations, healthcare, earthquake detections, radiation detections and hazardous gas detections, smartphone detections, water flow monitoring, and also traffic monitoring, wearable devices, smart door locks. So many modern applications nowadays we are using that IoT domain. And the application is moreover increases. So how the IoT will be evolved? IoT evolving, first we are using the pre-internet in the sense, we are communicate with human to human. In that time, smart networks we have to use. After that, IoT platform and services will be evolved. In there, we connect to the content only. After that, the smartphones and applications are used. In there, we are providing the internet of the services. First, we have to, before the pre-internet, human to human connections, and after the content will be processed to the internet, and after that, they provide the services to the users. And after that, smart devices, objects and tags. In there, the social media is famous in that. Those peoples are going to interact with each other. And after now, machine to machine communication is possible, device to device communication, device to human communication is possible. In their smart data and ambient content will be used, that is the Internet of Things. Each and everything will be connected to the internet, and it can be able to access by the users anywhere at any time. Current technological trends of IoT, we are 9 trends we are using the IoT. First thing is, we are growth of IoT, the devices will be human to device interactions, and voice user interface, it will be a reality. And finally, the real expansion of smart IoT and more edge devices will be a major trends. And also we are required that AI is a big player in the IoT field, and more investment, it will be a major trend. And digital twin technology, we are also using the IoT, and more social medias and all ethical issues will be raised in that. And current status and future prospects of IoT. In the current status, 2003, the connected persons will be a 0.08, the connected devices are 500 million, world population is 6.3 billion. After that, more connected devices than the people. After 2010, the people connected devices are 12.5 billion and 6.8 billion the world population. After that, 2015, 25 billion connected devices, world population is 7.2 billion. And 2020, 50 billion connected devices and 7.6 billion world population. So, the population is 7.6 in the 2020, the connected devices will be a 50 billion. Think about it. And after what is IoT versus computers? IoT devices versus computer, in the sense IoT devices which will be processed only the data producers and consumers are human being, that is internet of computer. After that, in the device, in the sense data producers and consumers are all the thing, that is all the data. This diagram illustrates that this is the internet of computers, these lines. Here the people generate, people gain, and people discover our data, and people can be purposed. After, in a physical world, it will be a worldwide of data, information can be shared by the users and knowledge will be shared, we get a solution. After IoT field, the thing can generate the data, gain that, it will be stored in the cloud and discover that, and thing can be processed. That will be a machine to machine communication. Next thing is trends in the adoption of IoT. We have three trends. One is the reduction in IoT component cost, end-to-end IoT platform. Last is the sensor analysis and fusion. Reduction in the IoT component in the sense, the cost will be reduced. For example, in an industry side, we are using the 10,000 people are working some machine. Now, the working people will be reduced. Instead of we are using the automated everything. So, the people working will be reduced. So, cost will be, the component of cost will be a reduction. And end-to-end IoT application, it will be a combination of devices, connectivity and data analysis software will be taking a place. Data analysis and sensor analysis and sensor fusion, in the sense, the sensor data analytics is a systems that can collect and analyze the relevant data and produce to our business. And sensor fusion, in the sense, we can not use our only heterogeneous sensors. No, we definitely use a heterogeneous as well as a homogeneous. So, we can combine a multiple data and get the data from the more precise one, and that data will be passed to the users. That is the sensor fusion. Next thing is relationship with embedded system. Embedded, it is a modern electronic component. It will be a low powered component units and can be used as some specific task only. So, in that embedded system, the bulk of electronic circuits can be embedded with that in a single chip. This is the embedded processing. Here, the peripheral hardware will be placed, that is the sensors, actuators or drivers. It will be connected with the embedded system. In the embedded system, there is the interface between the hardware devices as well as it can be ability to produce the connectivity services, that is the Wi-Fi, Bluetooth, Ethernet, or all the connectivities are embedded with that, and that data will be connected to the local network, and also it will be passes to the internet. After the data will be sent to the local network, that data can be sent to the web API, and there other devices or other users can be able to access that. And this is the embedded processing. Here the IoT devices with processing. Here we use a two processor because our IoT devices handle the more constrained resources. It will be a memory purpose, energy consumption and size. So, think that constraints, resource constraints, we use our two processor. One is the 16-bit processor, another one is the 32-bit processor. 16-bit processor, here all the sensors and actuators will be connected to this processor, and here we require a power supply. And next processor is a 32-bit processor. Here only a network connectivity only will be embedded with. These two things will be connected and make us some embedded, some single unit we can be integrated there. And next thing is technologies used in IoT. Lot of technologies we have to use. Here some of the technologies I am going to list out here. First one is the Bluetooth, second one is Zigbee, Z-Wave, Wi-Fi and EN Ocean technology. Bluetooth, in the sense, we have to exchange our data in a shorter range, shorter distance range. And Zigbee, it is specifically designed for sensors and control units. It will be a low cost thing. And connectivity, it will be widely for several applications, and Z-Wave, it will be a primarily used for home automation. It does work on with mesh network and using the low energy radio waves to communicate with the appliances in smart home devices. Wi-Fi, it will be used as a radio waves to provide a wireless high speed internet, and it will be provide some ranges compared with Bluetooth. The Wi-Fi will be more range of distance. IN version technology, it will be used for energy harvesting wireless technologies, primarily used for building automations. Here, combine the micro energy converters with the low power devices and enable wireless communications between the batteryless wireless sensors and also switches, controls and gateways. The EN version is primarily used for building automation systems. Thank you. We will continue in the next video.